honest with you, I'm not entirely sure what they were doing with the first part of construct understanding, so I'm gonna skip to the part where I think it's valid, which is on page 488, where it gives you this setup. So it says 108 degrees is the degrees inside the circle, and it's obviously out of 360 degrees, and then they want you to figure out what the arc length is relative to that. So assuming that it's a unit circle with a radius of 1, that would mean that I've got, well, a radius of 1, which means that my circumference is equal to 2 pi r, so it's equal to 2 pi when r is 1. So I want to find out what portion, so BP is going to be a portion of 2 pi, just like 108 degrees is a portion of 360. So it's kind of like that question we had before, where the arc length is going to be equal to the angle we're talking about over 360 times the circumference, which is 2 pi, and you could shorten this to be 108 over 180 times pi, because the 2 and the 360 cancel out. So because it's pi, we don't want to, if we're trying to find an exact value, we don't want to use pi, we just want to simplify the numbers around it. So I can look at this and probably recognize that 9 is a factor of 108 and 180. So I could take that out and it would be 12 pi over 20. And I can look at that and recognize that perhaps there's another factor that could come out, like 4, and divide each one by 4, and then I would have 3 pi over 5. So in terms of pi, the arc length BP is equal to 3 pi over 5. And this is pretty much our lead-in for radians, because what we're doing with radians is we're going to be chunking up the circle in terms of pi. So I'm just going to get rid of this information and keep the circle there. And we're going to show you how we're going to start dividing the circle up a little differently than we have before. So assuming it's the unit circle, then we start here at 0, and we know that the circle is 2 pi. So one full rotation. Instead of using 360 degrees, I'm going to do it in terms of pi, which is 2 pi for a full circle. Now that would mean that half a circle over here would be pi, and that 90 degrees up here would be a half a pi, because this is half of 2 pi, which means pi. This is half of pi, which means pi over 2. And then we could even go down here. This is 1.5 pi, or we could go 3 pi over 2 to express it as a fraction. Now the definition of a radian is linked to the arc length. So pretty much a radian is going to be somewhere in here where this is our radius, but the arc length is also equal to the radius of the circle. So in the unit circle, that would be 1. And that's the definition of a radian. So basically, I can say that 1, let's see how we work this out here. How many radians would we have in a circle? If I speak in terms of radians, I have 2 pi radians in a circle, which is equal to 360 degrees. So pi radians would then be equal to 180 degrees. So now we have the measurements that we're talking about on the top of page 489. They give you conversions between degrees and radians. So 2 pi radians, 360 degrees. Pi radians is just half of that, because it's half of that, which is 180. And so if I wanted to, this is basically pi times radians. So if I wanted 1 radian, I would just divide 180 by pi. So 1 radian, we'll call it a rad, is equal to 180 divided by pi, simply because pi times radians equals 180. So we've got a few different ways that we can express this, and I can actually do this the other way as well and go, okay, well, 1 rad is 180 over pi, so 1 degree rads times pi, well, it would just flip it upside down, and then I've got pi divided by 180. So, sorry, radians. So there's just the mathematical relationship, and you can kind of get, if as long as you remember that 2 pi radians equals 360, then you can sort of surmise the other ones. But if I were you, I'd just write it down on my cheat sheet, and then you can really quickly refer back to it. So that's going to lead us into the next portion. Just to quickly recap, 1 radian is equal to the portion of the circle where the arc is actually as big as the radius. And we're talking about chunking the circle up into portions of pi.